This question came in from a student from section 4.1, and it's a good question because it really assesses whether you understand what extreme values are and how we use the first derivative to find those extremes. So let's start by making sure we understand the information that we're given. Here's a copy of the question, and here's what we know from this. We know that it has a local, this f has a local extreme value at 2. So we know that f prime, the derivative of x at x equals 2, is either 0 or doesn't exist. How do I know that? From this part that I've underlined in black. We're given that f has an extreme at the point x equals 2. Next, we can pull out that f of 2 is 0. And we can pull out the definition for g and h, how they're defined in relation to f. So let's look at the first question, evaluate g of 2. So all we're going to do is put in, to find g of 2, we're going to put in a 2, g of 2 for x, so g of 2 is going to equal 2 times f of 2, which is 0, plus 5. So we can see that g of 2 will be 5. Let me show you that written out, and let me highlight as we go so that you can follow along here. If we want to find g of 2, we could start that with g of x as x times f of x plus 5. Replace the x with 0. Replace f of 2 with 0. And that would give us 2 times 0 is 0, plus 5 is 5. So there's g of 2. We can do something similar for h of 2. h of x is defined as x, f of x plus 5. So we could find h of 2 by replacing the x with 2. So 2, f of 2, which again is 0, plus 2 plus 5, and that is going to add up to 0 plus 2 plus 5, or 7. How about f prime of 2? And the reason we did this g of 2 and h of 2 is so that we can find f prime of 2 and g prime of 2. So really, this g prime of 2 and h prime of 2 are the pieces we're really getting at. But the g of 2 and h of 2 were necessary to be able to find those derivatives. If you recall, off to the side, and I don't want to confuse this too much with the f and g that were given, but if we had f times g, and you want to find the derivative of that product, do you remember that we do f prime g plus g prime f, the derivative of the first times the second, plus the derivative of the second times the first. So when we apply that product rule for derivatives, to find g prime of x, that's what we're going to use. The x, so if we're given x times f of x, the derivative of that is going to be the first times the derivative of the second, plus the second times the derivative of the first. And when we replace that x with 2, that would give us 2 times the derivative of f at 2, plus f of 2 times the derivative of x, which is 1. So that's just f of 2. We are given that f of 2 is 0. That's where this 0 comes from. And we're given that, let me highlight it here with green. assume that it has a local extreme at x equals 2. Assume that f has a local extreme at 2. So that's this right here. If it has a local extreme at 2, then f prime of 2 must be 0. So we could replace this f prime of 2 with 0. So we end up with 2 times 0 plus 0, or 0. What does that tell us? When g prime of 2, let me star this. If g prime of 2 equals 0, then what that tells us is there might be, we're not certain, but there can be an extreme at x equals 2. Because the derivative is 0, that tells us that there could be an extreme there. What the theorem tells us about derivatives equal to 0 is that if there is a maximum or minimum, so if there is an extreme, then it must happen at this place where the derivative is 0, or where the derivative doesn't exist. If the derivative is not 0, as we're going to find for h prime of 2, since it's not 0, we know there's not going to be an extreme at h of 2. So let's finish that. So h prime of x is given as the first, that's x, times the derivative of the second, plus the second times the derivative of the first. So we get x, f prime of x, and then times the derivative of x, which is 1. When we replace the x with 2, we get 0 plus 1, which is 1. So again, the extreme, if there is an extreme on h, we know it cannot happen at 2. So g could have an extreme at x equals 2, but h, because the derivative isn't 0, it's 1, h does not. So the answer to part B is C. G could have a local extreme at x equals 2, but h does not. I hope that this short video helps you with problem 4.1.83. Please let me know if you do need further clarification on any of those parts or how to interpret the derivatives.